This is the second video for fractions that have been taught in S1, just going over how people should be able to do this by the end of the topic. So far we've had a look at fraction of an amount, mixed numbers and proper fractions, simplifying and equivalence, and ordering. We're now going to look at adding and subtracting. The big idea behind adding and subtracting is we need to make sure that when we add and subtract fractions, they have the same name. By name, I'm talking about the denominator. Are the denominators the same? Here we've got 12 fifteenths, subtract 5 fifteenths. These have the same name. These are both called fifteenths. So if I've got 12 fifteenths and I subtract 5 fifteenths, I will have 7 fifteenths left over. As long as the name is the same, we can add and subtract, no problem. 3 14ths plus 4 14ths. Let's look at the name. The names are the same, so we can proceed as normal. 3 14ths plus 4 14ths is 7 14ths. But this example is different to the first one. 7 over 15 could not be simplified. They didn't share a times table. But you notice here that 7 and 14 are both in the 7 times table. So what we're going to do is we're going to divide both by 7, because you would always be expected to simplify your fractions. That's going to simplify to 1/2. You would always be expected to write your answer in its simplest form. If we have a look at this example here, 3/4 plus 5/6. Hopefully you can clearly see that these have different names. So what we're going to need to do is we're going to need to rewrite these fractions so that they have the same name. In order for us to do that, we're going to need to find the lowest common multiple of 4 and 6. That is the smallest answer in the 4 times table and the 6 times table. The smallest answer in the 4 times table and the 6 times table is 12. Yeah, that's the smallest number that's an answer in the 4 and the 6 times table. So we need to make equivalent fractions. And we say, okay, to get from 4 to 12, we've multiplied by 3. So we need to multiply this guy by 3. 3 times 3, 9. To get from 6 to 12, we've times by 2. We need to multiply this by 2. 5 times 2 is 10. So we've now made our equivalent fractions, and these equivalent fractions now have the same name. Now that they've got the same name, we can add them. 9 twelfths plus 10 twelfths will be 19 twelfths. This cannot be simplified. However, hopefully you notice that this is an improper fraction. The numerator is bigger than the denominator. So I'm just going to write this as a mixed number. 12 goes into 19 one time with a remainder of 7. So it's 1 and 7 twelfths. 9 tenths subtract 3/4. Oops. When we add and subtract fractions, we want to make sure they've got the same name. Hopefully you can see here that the names are different. Tenths and quarters are not the same name. We want to rewrite them so that they've got the same name, because it's easy to add and subtract fractions with the same name. So we want to find the lowest common multiple of 10 and 4. That's the smallest answer in the 10 times table and the 4 times table. The smallest answer in the 10 times table and the 4 times table is 20. So we need to ask, how did we get from 10 to 20? To get from 10 to 20, we times by 2. So I need to times 9 by 2. 9 times 2 is 18. We then ask, okay, how did we get from 4 to 20? Well, to get from 4 to 20, we times by 5. So I need to times this by 5. 3 5s are 15. (18 20ths subtract 15 20ths is 3 20ths. Okay? If we have a look here, we'll get mixed numbers now. There are lots of different strategies within the department for mixed numbers. I'm going to show you one of these strategies, but like I say, your teacher might have taught you something different. So here we've got 3.5 subtract 2 2/3. My advice for pupils is to convert these to be improper fractions. I showed you how to do this up in the first video, up here, on the top right. So to make this an improper fraction, we're going to do 2 times 3, which is 6. Then we're going to add on 1. That's 7. So this is going to become 7 over 2, subtract, I'm going to do something similar here, 3 times 2 is 6, plus 2 is 8. 7 over 2, subtract 8 over 3. That's just how I teach my pupils to do it. Your teacher might have taught you something different. Now this looks like a problem that we're quite familiar with from just the last couple of minutes. We are subtracting, so we want to make sure they've got the same name. Hopefully you can see here that these names are different. So we want to find the new name, and to do that we find the lowest common multiple of 2 and 3. What that means is what's the smallest answer in the 2 times table and the 3 times table. The smallest answer that's in the 2 and the 3 times table is 6. Okay. We then ask, okay, how did we get from 2 to 6? Well, to get from 2 to 6, we times by 3. So I need to times this by 3. And then I ask, okay, how did I get from 3 to 6? Well, to get from 3 to 6, I times by 2. So I need to times this by 2. That's 16, I think. We've now got things in the same name. We can easily add or subtract them. 21 sixths take away 16 sixths is 5 sixths. This cannot be simplified. It's a proper fraction, so I can't write it as a mixed number. That's me. The last thing I'm going to have a look at is looking at multiplication. Okay, so we've got 4 correct examples here, and that will be all the knowledge for S1 fractions. Okay, the first example is we've got 2/3 times 10/11. Okay, so 2/3 times 10/11. When we look at fractions, there's a couple of different strategies to do. We can multiply the numerators, multiply the denominators, and simplify. Or we could look at the diagonals and simplify first that diagonal and that diagonal. Okay, I'll talk through both ways. So if we were to just multiply the numerators, we're going to get 20. If we're going to multiply the denominators, we're going to get 33. These don't share a times table. There's no common factor, so that's your answer, 20 over 33. If we have a look at this example here, 3/5 times 4/9. You might just do this strategy here. I'm not going to do my working over here. Usually we do it underneath. This is going to become 12 over 45. But hopefully you can notice here that these are both in the 3 times table, and it's not immediately obvious that they are. But they're both in the 3 times table, so that can be simplified to be 4 over 15. That would be your final answer. However, I did speak about simplifying our diagonals, because maybe we could get that a wee bit easier. Do you notice that on this diagonal, we've got 3 and 9? Do you notice that they're both in the 3 times table? What we could do is we could divide both of these by 3. That divided by 3 is 1. That divided by 3 is 3. And then we can just multiply across now. Okay, so we've got 1 times 4, which is 4. 5 times 3, which is 15. Okay, either strategy is totally fine. I couldn't do anything with this diagonal because there was no times table that went into both. There was no common factor. Okay. Here we've got 5/6 multiplying 2 and 1/10. First issue is we've got a mixed number here. We want to write this as an improper fraction. So before I do any multiplication, 5/6 multiplying, so that's going to become 20 plus 1. 20 plus 1 is 21. So it's 21/10. And here I'm going to use this diagonal. So we could multiply across and then simplify. But here I'm going to look at this here because I noticed that this diagonal, I noticed that they're both in the 5 times table. I'm just going to divide both of them by 5 straight away. And see if I look at my other diagonal, I actually can see that they're both in the 3 times table. I'm going to divide both of these by 3. I'm going to multiply across now. 1 times 7, 2 times 2, which is 7 over 4. And then I'm going to write that as a mixed number. That's an improper fraction. We'll say how many 4s are in 7? 1 with a remainder of 3. 1 3/4. And finally, we've got 3 multiplying 2/7. Do you notice how this is a whole number? Okay, we've got a whole number multiplying this fraction. There's another way of saying this. I could write this as 3 lots of 2/7. And if I say it like that, that's 2/7, 2/7, and 2/7. Altogether, I've got 6/7. To see if we're ever multiplying a fraction by a whole number, that whole number just multiplies the numerator. 3 times 2/7 is simply 6/7. it is not 6/21. Okay, because it would just, how many of that name do we have? So that is not the answer. The answer here is 6/7. Okay, that's all the knowledge for S1 fractions. Hopefully that was helpful and will help you for any revision. Thanks very much.